Okay, hi guys. Today we're going to get started on our next unit, Unit 3, which is exponential form. So when we're looking at numbers, that little number right here, we have a big number, that's our base. This little number is called an exponent. And we've been dealing with exponents so far when we did cubes and squares. So for example, when we had x squared, or we had 2 squared, this had an exponent of 2. We've also been dealing with exponents of 3. Now we're going to take a look at numbers that have exponents bigger than 2 and bigger than 3, and sometimes less than 2 as well, and negative. So let's go ahead and get started. Okay, we're going to use the example that I used on the first page. We're going to use a 5 and a 3. The base, which is this number right here that I've circled, the base is the number being multiplied. So that's the big number. So it's the number that we are going to factor, or that we're going to multiply. And that's the big number. So think B and big. It's the big number. The exponent is the 3. That's the smaller number. It tells us how many times to multiply the base. That doesn't mean we multiply 5 times 3. That means that we multiply 5 3 times. So here's our base, it's 5. We need to multiply it out 3 times. So it's 5 times 5 times 5. And we know from Unit 1 that 5 cubed, or 5 to the 3rd power, or 5 times 5 times 5, is equal to 125. Okay, the expression in this case is just 5 to the 3rd. The expression, there is no equal sign. It's just a term. And sometimes it's a combination of terms. And then equivalent means the same as. So 5 to the 3rd is equivalent to 125. So this means that it's equivalent. So again, our big number is the base. The exponent tells us how many times to multiply out the base. So if we want to evaluate this expression, it's 5 times 5 times 5, and we get 125. So let me fill in the top up here, because I forgot to do that. A number is written in exponential form when it has a base, and again, that's the big number, and an exponent. That's the little number in the upper right. Okay, so let's take a look and see how. So in this example here, or these 4 examples, write each expression in exponential form. So what that means when it says write each in exponential form, it means exponential form means I need a base and an exponent. So if we take a look at number 1, what is the number that we're multiplying out each time? So we're multiplying 3. So 3 is our base. And our exponent tells us how many times we multiplied it. So we multiplied 3 1, 2, 3, 4, 5, 6, 7, 8 times. So our exponent is going to be 8. So this is 3 to the 8th. We don't need to evaluate it, we just need to leave it as 3 to the 8th. So if we look at example number 2, what number are we multiplying out each time? -6, -6, and -6. And keep in mind that it's in parentheses. So -6 is our base. How many times are we multiplying -6? We're multiplying it 1, 2, 3. So 3 is our exponent. Okay, example number 3 has two different bases. I'll underline them for you. It has x's and it also has z's. So that means we have two bases. We have a base of x, put a multiplication sign there, and we have a base of z. So we need to go back and count how many x's do we have? 1, 2, 3. So that's our exponent on the x. And how many z's do we have? We have 1, 2. So that is our exponent on the z. So it's x to the third and z squared. Now number 4 is a little bit tricky. We do have a base. The base is 9 because that's the only number we see there. How many 9s do we have? We just have one 9, so we can write this as 9 to the first, or an equivalent expression would be, we could also write it as 9. Either of those are the same. So if we just see one 9, it's 9 to the first power. Okay, let's take a look at how to go backwards. So in the next set, we're going to take a look at how do we take 3 to the 8th and write it in expanded form. So we're going to take the exponential form and write it in expanded form. So we have 4 examples here as well, 5, 6, 7, and 8. We want to see what is our base and what is our exponent. So in this case, our base can be a letter, so our base is A. And the exponent of 4 tells me how many times to multiply it out. So we have a to the 4th. So we're going to multiply a out 4 times. So 1, 2, 3, 4. That's it. In example number 6, our base is -3. The exponent tells me that I need 2 of them, so I'm going to multiply -3 times itself 2 times. And if we wanted to evaluate this, -3 times -3 is equal to a +9. Number 7. We have a base of 3. Notice that the negative sign is not inside the parentheses, so I'm just going to rewrite that negative sign over here. And the base that we have is 3, and I need to write it down 2 times. So my base is 3, so that means 3 times 3. And this is -3 times 3, so that's a -9. So let's just go over these two again. The difference between these two, number 6, the negative is inside the parentheses. Number 7, the negative is outside the parentheses. And it gives us 2 different answers. Let's take a look at example number 8. So we have 2 bases. We have a base of x, and we need 4 of those. And we have a base of y, and we need 2 of those. So we needed 4 x's and 2 y's. And we can't do anything else with that because we don't know what x and y are. So that is expanded form. Okay, next we're going to take a look at simplifying. So just like with any types of expressions, when we're simplifying expressions, we do parentheses first, then we do exponents, addition and subtraction from left to right, multiplication and division from left to right, and addition and subtraction from left to right. So let's take a look at example 9. We can't add or subtract anything because we don't know what some of these numbers are. So we can rewrite the square root of 25 as 5 minus 2 plus 3, we're going to put in parentheses, and that's also 5, and we're going to square it. So we can rewrite our 5 minus 5 squared is 25, and 5 minus 5 is equal to 20, -20. So our answer for this expression is -20. So again, simplify the square roots, add or subtract what's inside parentheses first, then take care of your exponents, and then just add or subtract from left to right. Let's try number 10. So number 10 is 18 minus 3 squared plus 6. The 18, can't do anything with it, minus 3 squared, we have to evaluate, and 3 squared is equal to 9, and then times 6. So we have to do multiplication and division first, so this needs to come first. So it's 18 minus 9 times 6 is 54. And then 18 minus 54 is negative 36. So 18 minus 3 squared times 6 is negative 36. So go ahead and try example number 11 on your own, and then check back with the video to check your answer. So again, we have to do what's inside parentheses first. So let's simplify what's inside parentheses. 12 divided by 3 is 4. 10 squared is 100. Can't do anything with this yet. Add up what's inside. 100 plus 4 is 104. Bring down the minus 4, and we get 100, and that's our final answer. So the quantity 12 divided by 3 plus 10 squared minus 4 is equal to 100. Okay, last two questions. We are going to substitute and simplify. And if you remember from last year what substitute means, for example, if I'm not here, somebody else comes in my place. So substitute means to replace. So for x squared, or x to the fourth times y squared, we are going to replace x with 2, and we're going to replace y with 3, and then rewrite the expression. So we're going to replace the x with 2. So here's our x. We're going to replace that with 2. Our exponent stays the same. We're going to replace the y with 3, and our exponent remains the same. And then we're going to write it in expanded form and evaluate. So 2 squared, or 2 to the fourth is 2 times 2 times 2 times 2, and 3 squared is 3 times 3. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 3 times 3 is 9. And 9 times 16 is 144. So evaluate, or substitute and simplify. Substitute just means replace the letter with the number. So go ahead and try the second example, and then check back on the video notes. So we are going to replace the letter A with the number 4. So I'm going to take out the letter A, and I'm going to replace that with the number 4. So I will have 4, and our exponent does not change. So how many 4s do I need? I need 4 times 4 times 4 times 4. 4 times 4 is 16, times 4 times 4. 16 times 4 is 64. Bring down my last times 4, and then 16 times 4 is 256. So the expression a to the fourth evaluated when a equals 4 gives us 4 to the fourth, and 4 times 4 times 4 times 4 is 256. Okay, so flip your paper over and take a look at the 3 sections on the back. I will do one example in each section. And so in section A, it says rewrite in expanded form. So keep in mind that expanded form is to write it out the long way. And the reason we use exponential notation is so that we don't have to write really, really long numbers, and you'll see why. So we write it out in expanded form. So 23 to the 7th means our base is 23, and we multiply 23 out 7 times. Times 23, and I know how to squeeze that in there. Okay, in section B, you need to write it in exponent form. And exponent form means we need to write it like we see it above. So our base is 4. How many 4s do we have? 1, 2, 3, 4, 5, 6, 7. So this is 4 to the 7th power. And then letter C, rewrite in standard form. So this we're going to get an answer to it. So 2 to the 10th is 2 times 2 times 2 times 2. We need it 10 times, recall. So that's 4, 5, 6, 7, 8, 9, 10. And then what does that equal? So if we multiply all those 2's out, we get 1,024. So standard form means what is the answer? Or what is the product? Okay, so I'll do one more. So 11 to the 3rd, we want it in standard form. So we know 11 to the 3rd in expanded form is 11 times 11 times 11. And if we multiply 11 times 11 times 11, we get 1,331. So we will check the other answers in class tomorrow. If you have any questions, please let me know.